This is a very interesting and the most important question in the inverse trigonometric chapter. We are required to find the sum of cot inverse of 1 plus 3 by 4 plus cot inverse of 2 square plus 3 by 4 plus cot inverse of 3 square plus 3 by 4 up to infinity. So the first thing which we do is we write the nth term of this series, which is cot inverse of n square plus 3 by 4. And we know that cot inverse of x is tan inverse of 1 by x. So this can be written as tan inverse of 1 upon n square plus 3 by 4. Now this is a very complicated term, and the basic formula which we know in terms of tan inverse is tan inverse A minus tan inverse B equals tan inverse A minus B upon 1 plus AB. So we try to convert this whole thing in the form of tan inverse A minus B upon 1 plus AB. Tan inverse A minus B upon 1 plus AB. So we try to create a 1 in the denominator. We add and subtract a 1 in the denominator just to create the one term which is present in this formula. This becomes tan inverse of 1 upon 1 plus n square minus 1 by 4, which becomes tan inverse of 1 upon 1 plus n plus half n minus half. Now this 1 in the numerator can be written as n plus half minus n minus half and the denominator as it is. Now we can clearly see this whole thing has changed to the format of tan inverse A minus B upon 1 plus AB. So this can be written as tan inverse of n plus half minus tan inverse of n minus half. Now this is the nth term of the series, and the sum of the series can be written as T1 plus T2 plus T3 up to Tn. So putting n equals 1, 2, 3, 4, we get tan inverse of 3 by 2 minus tan inverse of half plus tan inverse of 5 by 2 minus tan inverse of 3 by 2 and similarly all the other terms, like the third term as tan inverse 5 by 2 minus tan inverse 3 by 2, 7 by 2 minus tan inverse 5 by 2, putting n equals 3, and the last term will be tan inverse n plus half minus tan inverse of n minus half. Now we can very clearly see that the terms are getting cancelled. So the sum Sn gets converted into tan inverse of n plus half minus tan inverse of half. Now we want to find the sum up to infinite terms. So putting n equals infinity, this becomes tan inverse of infinity, and we know that tan inverse of infinity is pi by 2, and this tan inverse of x we can write cot inverse of 1 by x. So this becomes cot inverse of 2, and we know that pi by 2 minus cot inverse 2 is equal to tan inverse 2, which is our final answer. So the basic concept which we used in this question was to create the nth term of the series in the form of tan inverse A minus B upon 1 plus AB, so as to write it in the format of tan inverse A minus tan inverse B, so that the terms can get cancelled out and we can get a much simpler sum. Sum up to infinite terms is equal to tan inverse 2, and sum up to n terms of the series is tan inverse of n plus half minus tan inverse half.